Today we are going to be demonstrating how to perform and record the enhanced monitoring carbon monoxide readings as required under the EPA's Quad A NESHAP National Environmental Standards for Hazardous Pollutants Rule for municipal solid waste landfills. We'll be collecting the gas readings from wells following alternative method 143 using a GEM5000 portable gas analyzer equipped with a hydrogen compensated carbon monoxide electrochemical cell. To assist us following the method, we will use a handy checklist developed by Mike Neiman at EIL, Environmental Information Logistics. The checklist is available for download on the QED website, qedenv.com. You can print the checklist and write on it, or you can have the fillable PDF file on your computer or on a personal PDA, a tough pad, and fill the data in as you collect it. This fillable PDF can then show you whether or not you've passed the QA quality assurance requirements in this method. Hello everyone, I'm Aaron with QED Environmental Systems, and today we are going to demonstrate alternative method sampling for CO with QED Landtec GEM5000. So the first thing you want to do in your checklist is to verify that your battery's charged. So once this comes up, we want to ensure we have a valid certificate of analysis for our 1911 parts per million CO that we sell at QED, as well as a valid calibration certificate for this instrument. So as you see, we do have a full battery. One thing you also want to do is ensure that you have no moisture inside your water trap, and that your H2S filter that needs to be on your sample train is not discolored. This one's bad, this one is a fresh, brand new one, and that's what we have on our train. So the next thing we're going to do is perform a CO calibration. And we're going to go number 2, gas check, your user settings, and number 1. We'll scroll down till we get to our CO. And we have 1911 parts per million as our value. So at this time, we're going to go ahead and connect up to our CO and calibrate it. All right, we have our bottle open and we are connected. And we are going to let the CO move across our electrochemical cell. And then once we see a value that's somewhat stabilized, we're going to go ahead and start our check and calibrate the CO cell. We have somewhat of a stable value, so we're going to start our check, and it's going to take 60 seconds to complete this. Okay, it came in at we're going to go ahead and calibrate. And it's coming in at 1912, so we're looking good. 1911. We're going to go ahead and exit out. And now we're going to perform our sampling apparatus leak check. And we're simply going to do that from the, again, from the user calibration gas screen. We're going to start our pump. And what we're going to do here is, once we get somewhat stable of a reading, we're just going to pinch our hose, our sample train, or that's if you're using it on demand. Today we're using a fixed flow regulator, so we're just simply going to close the valve and watch for our pump to fail. And we don't want to see an increase in our oxygen of more than 5%. Excuse me, 0.5%. See our pump starting to labor, keep going red. There's our pump failing. We did not see an increase in our O2, so we've satisfied all these requirements. Now we're going to move on to our weekly stability sensor test. To do our weekly sensor stability test, we have our bottle open and we're connected. We're going to start our pump and we're going to time it. At 240 seconds, you record the value, and then again at 300 seconds. Okay, we are at nearly 4 minutes, which is 240 seconds, and we're going to record. 1919 is going to be our number for our 240 seconds. Okay, so we're nearing our 5-minute mark, or 300 seconds, and our value looks like it's going to come in around 1922. So we're within the 2.5% that you need to pass. So we're going to move on to our next test, which is going to be our daily response time test. Now we are performing the daily response time, and we've purged the instrument to clear the CO out of the cell, and we are connected to the CO, and we have the valve open, and we're going to start our pump. So we've almost reached our target value of 1815 with the standard, and we did at 43 seconds. Now we will do the same to ambient, which is 0, and we're looking for 96, and we're going to record that time as well. So now we're looking for our standard to come down below 96, which it just did. 27 seconds, we're going to call that one. So our purge time is going to be the higher of the two. Response time is going to be 43 seconds. Okay, our next test is going to be for the instrument air test. And we are going to perform our low-level standard first. And then we'll move on to our high-level standard. So we've purged our instrument to do our IE test, instrument air test. And it looks like we're coming in around 7 parts per million CO. And then we're going to stop the pump and connect up to our bottle and do our high-level standard. Okay, so we've reached somewhat some stabilization with our CO. It looks like we're coming in around 1922, and that's the number we're going to use. 1923 we're going to use for our high-level standard reading. And that puts us within the 5% to pass this test. And now we can move on to our well. So we're going to go ahead and take the test sample at our well. The purge time has been automatically calculated via this form. So you can see our 47 seconds was the highest time in our response time. So now we're going to calculate 1.5 times. 64 seconds is what we're going to start our clock and purge for 64 seconds on the actual well. From the gas user screen again, you do have a countdown on your screen. So you can either do it this way, or you can just watch the seconds tick off on your gas screen. Okay, now that we've purged for 64 seconds, and during the whole duration, we were watching our CO to make sure that there is no hydrogen present. You can see that it's green. It'll turn to a yellow and then a red. If you see that, you should probably disconnect from the well. The threat to damage your cell is present at that point. So now we're going to switch to special action. 6, start logging. We want 60 seconds, a 1-minute reading. And then we're going to press 3 because we want 5 readings. And we're just going to go ahead and start our logging process. And it's going to count down and start taking the series of 5 readings. It's going through a warm-up right now. Once this warm-up is complete, it will start taking the readings. So we're almost down to the last 10 seconds of our first 60-second reading. And again, you want to pay attention to your H2 to make sure that that indicator does not move into the orange or to the red. That would cause you a problem. So it saved our first reading, and now it's going to go on to its second reading, third and fourth and fifth. So we are on our last reading. We're down to 10 seconds, and it's going to log this last reading. Then we are going to move on to our final instrument air test. So after your sampling, before you move on to your final instrument air test, you want to go over this and make sure that the sensor wasn't exposed to 80% of its range. So it's 2000 is the range, so that would be 1600. Did not. The analyzer did not return to 0, plus or minus 20 parts per million, which it did not. Filters indicate that they require replacement, which they do not. Filters exposed to abnormal conditions, liquid, those type of things. And is this the end of your sampling? If you answer yes to any of these, you must conduct an IE test. Okay, now we're going to perform our final instrument air test. And to do that, we're going to again connect our bottle, open it up, and from the user gas screen, we're just going to start our pump. Okay, so we've come in around 1946, and that's the number we're going to use. Okay, so we've used 1946 as our value, and now we're purging to ambient again to get our low-level standard for our final IE test. Okay, so we've purged for about 100 seconds or so, or maybe a little more, and we're down to 8 showing on our CO. So I guess we'll use that as our number. I'm going to stop the pump. We're going to put 8 in there, and that's going to auto-calculate our drift test. Okay, so we now have 8 as our low-level standard. We've input that into the field, and we're going to scroll up to see our auto-calculated drift. And this shows that we are within the allowance, and this is a validated test.